Lesson 2.5, Evaluating Absolute Value Expressions. Our essential question today is how can two different numbers have the same absolute value? We have one new vocabulary word, it's absolute value. Absolute value means the distance from zero on a number line. So our next question is, what two numbers have an absolute value of 7? So I want you to think about the definition that we just wrote. If absolute value means the distance away from 0 on a number line, now this question means what two numbers have a distance of 7 away from 0 on a number line. And if you think about what a number line looks like and where the number 0 is, if you move 7 units to the right, that takes you to the number 7. If you move 7 units to the left, though, it takes you to a different number. That number would be -7. So to answer this question, what two numbers have an absolute value of 7, I would say 7 and -7 both have an absolute value of 7. Because they are both 7 units away from 0. So just about every number on the number line has another number with the same absolute value. We'll think a little more about that later. Okay, so now what is the value of each of these? So the absolute value of 5, well, 5 is 5 units away from 0. So that absolute value is 5. This next example, though, has a negative sign out in front of the absolute value. So if I evaluate the absolute value of -5 first, that's 5 units away from 0. Then, if I put the negative out in front, it actually makes your answer a negative. So, inside of the bars, when we evaluate that distance, remember a distance is always positive. You can't measure a distance and get a negative number. So the absolute value of 5 is 5. The absolute value of -5 is also 5. But the negative out in front of the absolute value bars, you can think about that one as meaning the opposite of. So you put that one on at the end, and it turns your answer into a negative. Okay, this third one, -5 is 5 units away from 0. So the absolute value of -5 is 5. Hopefully you remembered from a previous class that those two straight bars, those bars on each side of the number, that's the symbol for the absolute value. The two straight bars. And it means distance away from 0. Okay, the absolute value of 5 is 5. But on this one, again, we've got the opposite or the negative sign out in front. So this answer would be -5. So a common assumption is that anytime you see these bars for absolute value, your answer is going to be positive. That's true for what's inside of the bars, because whatever's inside the distance, the absolute value bars, will turn that into a positive. It's just that if there's anything else in the problem outside of those absolute value bars, that can change your final answer. Now we're going to do some evaluating. So we're going to evaluate some absolute value expressions. So some of our answers will end up positive, some will end up negative. You just have to follow PEMDAS. PEMDAS is the order of operations, and where absolute value bars fall in PEMDAS would be where the P is for parentheses, because they're like a grouping symbol. So if I plug in my numbers here, y is -3, so I'm going to put the -3 where the y is, and then I've got my -7, and then I have plus x, which is 5. So I substituted 5 for the x and -3 for the y. Now I need to simplify inside the bars. -3 minus 7 is -10. The absolute value of -10 is +10. So 10 plus 5 is 15. Simplify inside of the bars, just like you do with parentheses, until there's one number left. Then take that absolute value. Okay, my next problem, I have 3 minus, and then x is 5, and then I have -2 times y. All right, so 3 minus 5 is -2. The absolute value of -2 is +2. Now, I'm done with my absolute value, so following PEMDAS, the next thing I need to do is multiply. So, I multiply -2 times -3, which is +6. So 2 plus 6 is 8. Our next example, evaluating again, we just need to get a lot of practice with these. The values for x and y have changed on this one. So I have 2 times x, and then it's minus y plus x minus y. Okay, so I've substituted -2 for each x and +4 for each y. Inside my bars, I would have to multiply first. 2 times -2 is -4. So -4 minus 4. And then I have -2 minus 4. -4 minus 4 is -8. -2 minus 4 is -6. The absolute value of -8 is 8. And -6 is 6. So my final answer is 14. One more on this slide before it gets a little bit trickier on the next one. So 4 times y, which is 4, minus x times y, plus 2 times the absolute value of x. All right. Inside these bars, 4 times 4 is 16, minus -2 times 4 is -8. This turns into a chunky plus. Minus -8 turns into +8. So 16 plus 8 is 24. The absolute value of 24 is 24, plus the absolute value of -2 is 2. Then I would need to multiply for PEMDAS. 2 times 2 is 4, so 24 plus 4 is 28. Hopefully you're seeing that you just need to take your time and really solve these step by step and use PEMDAS. If you skip steps, you will more than likely make mistakes on these problems. So you need to just take your time, one step at a time. So first plug in your numbers. So 12 minus, and then I've got x minus y, and then plus z. And I'm trying to be really careful when I plug them in and just show you in red that I've got the value -2 for x, 1.5 for y, and -4.1 for z. Because the signs that are in the problem for the operations, like the minuses and the pluses, I'm leaving those in black so that you're not getting hopefully getting confused about how many negatives there are and where they're at. So 12 minus. Negative 2 minus 1.5 is negative 3.5. So negative 3.5 has an absolute value of positive 3.5. And now I just need to use PEMDAS. 12 minus 3.5 would be 8.5 plus negative 4.1 is like 8.5 minus 4.1, so it's 4.4. You will see decimal problems on your homework. So if you need to use a calculator, use a calculator. All right. Our last example. I have a negative out in front of the bars. Inside I need y plus z. Okay. And then I have minus 3 times x. Okay. So inside my bars, 1.5 plus negative 4.1 would be negative 2.6. The absolute value of negative 2.6 is 2.6, but the negative out in front makes it look like it's back to being a negative. So that doesn't turn into a chunky plus. It's when the absolute value bar, so I'm talking about this part right here, when the absolute value bar has a minus in front of it and a negative after it, that doesn't turn into a chunky plus like a parenthesis would. So that's an important thing to point out. Next, with PEMDAS, I would have to multiply. A negative 3 times negative 2 is positive 6. So negative 2.6 plus 6 would be 3.4, positive 3.4. All right, you should be able to write a summary now and then check with your teacher to find out what your assignment is. Make sure that you restate the essential question and write complete sentences for your summary.